Afternoon. I've tried doing this several times already, involving whiteboards and things, but you can't see them. So every so and then bing, and we're going to do some magic, and things are hopefully going to appear there. It's not going to happen, is it? It's going to be awful, but it's worth a try. I want to get a head start on, for some of you, on college courses. I know personally, hopefully I know personally some of these viewers who better watch this, otherwise I will hunt them down, and other threats that will get me thrown off YouTube. Anyway, we won't worry about that. You're going to college, you're going to be doing theatre or production technology. And it always helps if you can get one step ahead. As I know what you've been taught in schools. I'm not impressed. It's certainly nothing like when I was at school and when I was at college doing this. It's pretty poor. We're going to treat this as sort of what is electricity 101, and just very, very quickly go through one or two things that hopefully I can get written up there. The first thing, what is electricity? Well, it's a little bunch of electrons. If you want a really awful and terribly inaccurate definition of what electricity is, it's measured, electrical charge is measured in coulombs. Well, that's not going up there. I haven't done my ping. It's not going up there. You don't need to know. A coulomb is roughly 1.24 times 10 to the 18 electrons. That's an awful lot. You could easily pick them up. They would equally easily kill you. So you don't. The first thing then you need to know is an amp. It's a unit of current. An ampere, named after a French guy called, I think, Anton Marie Ampere, I think. Not entirely sure. An amp is 1 coulomb per second. It's a rate of flow. It's a number of electrons passing a point in 1 second. Whatever it was, 1.24 times 10 to the 18 electrons flowing past a point in 1 second is 1 amp. 2 coulombs per second is 2 amps. 3 coulombs per second, you get the idea. That is the amount of electricity. It's quite critical because it's literally the difference between life and death. The thing that causes those to flow is voltage. Voltage is a pressure. It's what forces these electrons down the wire. That's measured again. That's Voltaire, again a Frenchman. The French were quite good at naming bits of electricity. And I don't know what the definition of a volt is. We can define it. We'll probably define it when we do Ohm's law in a video or two's time, because it makes more sense to do it that way. And voltage is measured in volts. Sign and symbol are both V. And the last one you need to know at the moment is resistance. These are the basic building blocks of all weird electrical calculations. Ooh, excuse me, dirty little piggy. Certainly for DC, and at the level you're working, this is fine. Resistance, that's the ability. If you've got the volts coming this way, and you're pushing back that way, that's the resistance. And the higher the resistance, the more volts you need to push the same current. And we'll see that again in Ohm's law. And resistance is slightly different. Ohm. I don't know who invented resistance. I'll have to have a look. I'll look that up for the Ohm's law one. Its symbol is R, or is that the sign? There's a difference between sign and symbols. Resistance R, if you see R, you know it's resistance. And it's measured in ohms, and it's the last letter of the Greek alphabet, which hopefully is appearing there. It's a capital omega. It's a funny shaped thing. I'll do it on the board just in case I can't get one to show. So I can see a big omega appear, and just like it's, look, there's writing on there. I'll just get rid of that. It's probably from an early attempt. There you go. That's an omega. That's a capital omega for you. That's what hopefully is appearing up there. I haven't done any pings, but my machine's psychic. It knows when I want them. That's the 3 basic things you need to learn. The next video we're probably going to play with Ohm's law, which is about those 3. and how they work together, and they do work together. They work together really well. Ignore them at your peril. Get it wrong, and terrible things happen. Fire is a common one, and death and destruction and lawsuits. That's not quite so much fun anymore, is it? But we'll look at Ohm's law next. Hopefully we can do that in 5 minutes, and then we'll move on to something else. See you all soon.